So you've been looking at some expressions and you've been doing some substitution, and we're just going to have a look at an example here. 3x plus 2 is an expression and it has algebraic terms. It's got x and it's also got numbers. 3x plus 2 can be given lots of different values by substituting in different values of x, and we're just going to look at a few examples. So the first example, when x equals 7, we know that 3x plus 2 is going to become 3 times 7, because x is now 7, plus 2. And 3 7s are 21, plus 2 is 23. So 3x plus 2 becomes 23. When x is 0.5, then 3x plus 2 is 3 times 0.5 plus 2. 3 times 0.5 is 1.5, and when we add on 2, we get an answer of 3.5. And finally, when x is negative 5, then 3x plus 2 becomes 3 times negative 5 plus 2. 3 times negative 5 is negative 15, and we need to add on 2. If we come down to the number line at the bottom of the page, we've got negative 15. We know that when we add on 2, we're going to go to the right. Our number is going to increase by 2, so it goes up to negative 13, and so 3x plus 2 becomes negative 13. So it's important that you take note of the language that we're using here. Expression is a very key part of algebraic language, and 3x plus 2 is an expression. It takes lots of different values, as we've just shown. But what we can do is we can take that expression and we can make it equal to a certain value. And what we've done here is taken 3x plus 2 and said that it must equal 8. This becomes an equation. An equation always has an equal sign. It involves algebra, and there is a particular value that needs to be found. In this case, and in lots of cases, we use x. So the question is, what is the value of x? Now, on the previous page, we tried different values. We know that when x equals 7, then 3x plus 2 equals 23. We know that when x equals 0.5, that 3x plus 2 equals 3.5. And we know that when x equals negative 5, that 3x plus 2 equals negative 13. Now, our equation involves 3x plus 2, but it gives us a very specific answer. We want 3x plus 2 to equal 8. And we know that x cannot be any of these values, because none of those values have given us an answer of 8. So what is the value of x that makes this equation true? Now, you may already be thinking that you know the answer. We're going to have a look at it. So 3x plus 2 equals 8. What this is telling us is that there is some value of x which, when it is multiplied by 3, so that we make it 3x, and we add on 2, we get to 8. So we can work out that the value of that 3x must be 6. And if the value of 3x is 6, then we can go on to work out what the value of x is. If we have 3 x's and all of those x's have to be the same, then each individual one must be 2. So I expect you've already realised that x equals 2 is the answer to the problem that we're solving with an equation. Now, whenever we have an equation and we get an answer, we can always check it. We can say, well, what happens when x equals 2 to our original expression of 3x plus 2? And 3x plus 2 becomes 3 times 2 plus 2. 3 2's are 6, and when we add on 2, we get 8. And so x equals 2 is the correct solution to our equation. Now we're going to have a look at the equation in a bit more detail. Because we have an equal sign, then that is telling us that both sides of our equation are the same. We have a left-hand side and we have a right-hand side. On the left-hand side we have 3x plus 2, and on the right-hand side we have 8. And because they are equal to each other, we can draw them as balancing scales. And we've got some scales here. On the left-hand side, we've got 3 identical balls that are each have a value of x, and we've got a box with a value of 2. That represents our 3x plus 2. And on the right-hand side, we have a value of 8, which has been split up into a box worth 2 and a box that's worth 6. Now, you can see that the scales are in balance because they are nice and level. And what we want to do is we want to try and work out what that value of x is that is making these scales in balance. So the first thing I'm going to do is to take away that box on the left that is worth 2, because I want to know what the x's are worth. So if I take that box away on the left-hand side, then the 3 x's that are left are now going to end up, if we're not careful, with an imbalance like we've got in this diagram on the right-hand side. Because the 3 x's, because the left-hand side has had that 2 taken away, the 3 x's are now lighter and they're worth less than the 2 and the 6 on the other side. And we can see very clearly that our scales are not in balance. And when we're solving equations, it is very, very important that we keep our scales in balance, because then we don't have an equation. So if we have taken away the 2 from the left-hand side, we must make sure that we do exactly the same to the right-hand side. So I'm going to take away the box that is worth 2, I'm going to cross it out and remove that value from the right-hand side. And now my scales are going to be in balance. So I can see, you can see, look, going down to the second scales, that we're left with 3 x's on the left and with a box worth 6 on the right. And we are still in perfect balance because we have done the same thing to the left-hand side. We've taken away 2, and the right-hand side we've taken away that 2. Now we've just got x's. We've got 3 balls that are worth x, but what I actually want to know is what each of those x's is worth. And you can see that if we make each of these balls worth 2, that they will then be in perfect balance with the 6 on the other side. And so the value of our x must be 2. Now we have another example here of balancing scales. We can see that they're perfectly in balance and that we've got a lot of circles and bricks on the left-hand side and a lot on the right-hand side, and they must be equal to each other. Whatever's balancing on the left and whatever's balancing on the right, they must be equivalent. So we're going to just try and find out what x is by removing boxes or circles from both sides. You can see that on the left-hand side, we've got 2 circles that are worth y, and on the right-hand side, we also have 2 circles that are worth y. And so we're going to take both of those away, and we're still in balance. The most important thing to bear in mind here is that whatever you do to the left-hand side, you must do the same to the right-hand side. I'm not allowed to take anything from one side, or we're going to end up with imbalanced scales like we had in one of the diagrams on the previous page. I'm going to take away 1x from the left and 1x from the right. I'm going to take away a second x from the left, and a second x from the right, and a third x from the left, and a third x from the right. I'm still left with some x's on the right-hand side, but I can't take those away because I don't have any x's left on the left-hand side, and I must only take away what is on both. I've got a box that's worth 10 on the right-hand side, and I wonder whether or not I can take that box away. I haven't got a box on the left-hand side that is worth 10, but I do have two boxes that are worth 6 and 4, and together they make 10. So if I take away both of those two boxes and take away the 10 box on the right-hand side, my scales are still in balance. I can't take anything else away now because there is nothing that is on the left or the right-hand side that are the same. But I know that what I'm left with, I'm still in balance. So on the right-hand side, I've got two balls with a value of x, and on the left-hand side, I've got a number 11. Now what that tells me, because both of these x's must be worth the same value, they must be identical. So I've got to share this 11 out between these two balls of x. So each ball must be 5.5, because if I add together two 5.5s, I get my 11. So the solution to this balancing scales is that x must be 5.5. It's the only solution that will work. Any other value of x will make it so that the scales aren't in balance. So we've looked at equations by representing them on balancing scales. They're allowed to be balancing scales because the equal sign tells us that the left-hand side and the right-hand side are exactly the same. So what I'd like you to do now is to copy these notes into your exercise book. The title is Solving Equations. The box is what you must copy into your book. You can pause this video so that you can copy it in. And then at the bottom of the page, there is an exercise in your textbook that you can do. I've made a copy of this because some of you may like to print it out so that you can cross things off. You don't have to do that, but you may like that to do that if it helps you. You don't need to draw the diagrams in your exercise book. You do need to give your answers, just as x equals. You can check your answers from the answer book. If you get any of them wrong, then go back and have a look at how you have taken things away from both sides of your scales and whether you've accidentally taken something from one side that you couldn't take from the other side. If you've got any questions on this, then you need to just contact your teacher.